Hello, class. So we were at the culmination. We've done so much this semester, and now it's time to put it all together and show off all that you know. And so I want to talk a little bit about your final presentations. So I'm going to share the screen. And we'll go to our OAKS page. Okay, so right now I'm in Module 8, and some course materials that we have. The assignment here is the government briefing, and then there's a couple sub modules here with the two types of problems that we talked about on day one of the class, the NSA problem and the MIT flight path planning problem. You now have enough knowledge to solve these. And so what we're going to do is you're going to think about each one of these, you're going to return to these with your team. It's a group assignment, and you're going to give a presentation on each one. You have a choice though. Do you want to present it as to a technical audience? So you choose which problem you'd like to do to a technical audience, and that you have to do a 15-minute presentation and record it and do it as a team. Or you can choose to do it as a presentation to a non-technical audience. In both instances, because these sort of have some military bent to them, we're going to pretend this is a government briefing. That's the way they do presentations. And so if you choose, say you're the team that chose to do the NSA problem to a technical audience, you can assume that it's almost like a conference, a government briefing to your peers and colleagues. So people that know just as much math as you. So whatever division you're in there at the National Security Agency, you and your team are presenting this to other folks there in that division or other divisions that are just as skilled with you. They know just as much operations research and optimization, mathematics, statistics. If your team then chose, that means the other problem, the MIT flight path planning problem, also has sort of a government spin. So we're going to say this is a government briefing as well, but you would have chosen this one to the non-technical audience. So now you want to think about doing this to, probably it's going to be higher up. So this would be colonels and generals and leaders. And they don't know as much math, but they're very interested in this problem and its application. And you have only 7 minutes to show them to present your work. Okay, so those are two things. Again, you have a choice with your team to do it. And I just want to talk a little bit about the documents in here. So each one has 2 documents. So let's take a look at the NSA problem. The first document you're going to pull up is a unclassified. It's from the National Security Agency. And so I actually worked in this R55 division with this guy, Dr. Currit. He was a professor who turned to work at the NSA, got much better pay and more time with his family. So I was part of something called the SPORT program. It was like a summer program for operations research training. So I was actually where you are right now. I had finished 1 year of graduate school and spent the summer there. And since went back after I got my doctorate, I've consulted with them on smaller projects. But in doing that SPORT project, I had to go through quite a bit of background evaluation and security and clearances, which was all helpful for the future. That program, I believe, still exists. In fact, one of our former students, Caitlin Manley, is working there full time. Okay, so in this project, in this particular paper, there are the 2 models that we talked about on day 1 of the class. There's 2 types of general problems, and you'll see the models there. This was so it's an early draft, it's not complete. You'll see there could be some typos in grammar and etc. Let's see. And so we want to get to, you really want to focus though in both instances, the network diversion and then the herding problem are the 2 names of the problems. A couple examples. These are old, you might want to monerize, make your own graphs and instances. But here's the model. So you really want to focus on this model for the technical audience, describing this, understanding it, maybe talking about particular cases. Understanding, you should, with your team, make sure you understand why each constraint exists, what it does, why the variables are the way they are. And let's see, and then now it was tested on some networks, again, very old, right? These are really old timings, so you may, in semesters past, some teams have sort of tried to monetize those. Some teams have implemented it and run it, so they actually got timings for the machines that they were working on. Okay, let's back up. Now the other one is the, so this is a patent that actually to get all optimal solutions associated with this problem. And just to give you, you don't have to, go in maybe as much detail of reading, because reading patents is a whole other work. And in fact, I've gotten really good at it. For consulting, I've worked on now 3 different court cases with patent infringement. So, but that's a skill to learn, and I'm not asking you to, but it's just a neat to see that you can patent an algorithm applied to a particular application, not an algorithm itself, so you couldn't apply the algorithm Dr. Clark created, get a patent for that, but apply to this particular application, which is communication networks. Anyway, it's just something to see and take a look at. I think some of you might be interested, so that's there. If you want to add, if you gained anything from that and want to add it to your presentation, you're welcome to, but it's not required. Okay, let's go back. So that's NSA, and then I want to talk about these 2 papers here for the MIT flight path problem. One was a paper I worked with these folks here. This is the guy that generated the problem at MIT Lincoln Lab. This was a student at the College of Charleston at the time, year age. He just finished this class and spent the summer doing this projects class or problem-based learning class at NC State. Another student at the time, they had since written this as a paper and submitted it. So this was a conference paper. It's a nice short one. But I just want to talk about the problem and the parts of this paper that we understand. So there's some parts of this that you don't have to focus on. Oh yeah, this one's just a little 2-pager, right? Okay, so you can read through this whole thing, no problem. Let's go back to the other one. So this was the longer paper that was submitted at NC State University as part of that project, problem-based learning. These are the team of students that worked on it, a couple of faculty advisors that helped, and the guy that presented it. So there's several sections in here, and there's some that you don't even have to worry about. So the discrete model is the main one. They did a shortest path problem. Those are some things that you can understand. Some pictures and visualizations. Again, you could maybe want to update. Here's the linear program. That's right up your alley. This is the part you really want to focus on. Make sure you understand each piece of this, why it's there, maybe make it small examples, like make a little network and understand each piece. You can read this, but you don't have to present. The stochastic model, again, kind of interesting. Markup chains or something we'll probably do next semester in 452, 552. And then the next one. The continuous model. Again, you can read it, but don't present it. This one actually did not work well at all. The best model was that linear program at the beginning, by far. This one had very short, could only work on super tiny problems, but they were actually making a function that would go through that, trying to create an f of xy. Couldn't do it in higher dimensional space, so that was a real shortcoming, and it was super expensive. You can read it, but again, don't present those. Those are beyond the scope of our class because we didn't do continuous models. So okay. Back to module 8. Okay, so then again, you're going to create your final product is 2 presentations that you and your team make. One is a 15-minute one, one is a 7-minute one, aimed at the 2 different audiences. And you have to also make questions. So if you read the assignment here, you need to have questions ready for other teams. So you'll be evaluating. We'll probably do this live during the final exam time. Also let you present. So we'll make a recorded one, we'll do a live one, and you can ask questions of the other teams. That's kind of good. And then just some suggestions. So take a look at that document. Okay, I think that's it. It should be fun, and again, you can see how far you've come this semester and dig deeper into these problems. All right, enjoy it.